fractions with equal denominator. The rectangle is divided into 5 equal parts. We can see that 3 parts out of the 5 equal parts are colored. Now, if we want to represent this as a fraction, we write it as 3 upon 5. The colored parts 3 become the numerator of the fraction. The total number of equal parts 5 become the denominator of the fraction. Now, let us consider a few fractions. 4 upon 9, 2 upon 7, 3 upon 5, 1 upon 9, 5 upon 9. Let us divide these fractions into 2 groups. We can see that 4 upon 9, 5 upon 9, 1 upon 9 all have the same denominators. So put these in group 1. These fractions 2 upon 7, 3 upon 5 have different denominators. So put these in group 2. Fractions which have equal denominators are called fractions with equal denominator. Exercise 25, question 1. Write fractions to represent the colored part of the figure. Group together those with equal denominators. Solution. We can see that the circle is divided into 8 equal parts. Therefore, 8 is the denominator. 3 parts are colored. Thus, 3 is the numerator. The fraction is 3 upon 8. In the second figure, we can see that 1 part out of 4 equal parts is colored. Thus, numerator is equal to 1, denominator is equal to 4. Fraction is equal to 1 upon 4. In the third figure, 2 parts out of 4 are colored. Thus, numerator is equal to 2, denominator is equal to 4. Fraction is equal to 2 upon 4. In the fourth figure, here 1 part of 6 equal parts is colored. Hence, numerator is equal to 1, denominator is equal to 6. Fraction is equal to 1 upon 6. In the fifth figure, 5 parts of 8 equal parts are colored. Thus, numerator is equal to 5, denominator is equal to 8. Fraction is equal to 5 upon 8. In the last figure, 5 parts of 6 equal parts are colored. Thus, numerator is equal to 5, denominator is equal to 6. Fraction is equal to 5 upon 6. Exercise 25. Question 2. Say whether the two fractions in each pair below have equal denominator. 1. 2 upon 5, 3 upon 5. 2. 5 upon 7, 4 upon 7. 3. 7 upon 9, 7 upon 11. 4. 13 upon 16, 9 upon 17. 5. 6 upon 15, 15 upon 17. 6. 11 upon 19, 9 upon 19. 7. 1 upon 22, 5 upon 22. 8. 9 upon 64, 11 upon 64. Solution. Out of the 8 pair of fractions, we can see that the first pair 2 upon 5, 3 upon 5. Second pair 5 upon 7, 4 upon 7. Sixth pair 11 upon 19, 9 upon 19. Seventh pair 1 upon 22, 5 upon 22. All pairs have equal denominators. All the other pairs of fractions have different denominators. Question 3. For each of the following fractions, write 3 more fractions with equal denominators. Solution. Here, d is equal to 7. Therefore, 3 other fractions with d is equal to 7 are 1. 2 upon 7, 4 upon 7, 3 upon 7, 6 upon 7 are the 3 other fractions with denominator 7. 2. 3 upon 8. Here, denominator is equal to 8. Thus, 3 other fractions with denominator 8 are 5 upon 8, 4 upon 8 and 7 upon 8. Now let us see how we can compare fractions with equal denominators. Let us consider two fractions, 3 upon 5 and 2 upon 5. Now we have to say which of the fractions is bigger or smaller than the other. In fractions with equal denominators, the fraction with bigger numerator is the bigger fraction and fraction with smaller numerator is the smaller fraction. Among the fraction 3 upon 5 and 2 upon 5, the numerator 3 of the fraction 3 upon 5 is greater than the numerator 2 of the fraction 2 upon 5. Since 3 is greater than 2, hence 3 upon 5 is greater than 2 upon 5. Now, let us take the same example and understand it in a simple way. The first fractions given are 3 upon 5 and the other is 2 upon 5. Let us think that a rectangular cake is divided into 5 equal parts. Now if 3 pieces out of these 5 equal pieces are given to me, we can show it as 3 colored parts. This fraction can be written as 3 upon 5. Now, if I am given only 2 pieces out of the 5 equal pieces, we can show it as 2 colored parts. This fraction can be written as 2 upon 5. Now, 3 pieces of cake are greater than 2 pieces of cake. Thus, the fraction 3 upon 5 will be greater than the fraction 2 upon 5. Let us solve exercise 26 based on comparison of fractions. Question 1. Write the fractions to show the colored portions of the given figures and tell which fraction is bigger. Solution. We can see that the pentagon is divided into 5 equal parts. So the denominator of the fraction will be 5. Only one part out of 5 equal parts is colored. So the numerator of the required fraction will be 1. Thus, the fraction will be 1 upon 5. See the next figure. We can see that the pentagon is divided into 5 equal parts again. So the denominator of the fraction will be 5. But here, only 2 parts out of 5 equal parts is colored. So, the numerator of the required fraction will be 2. Thus, the fraction will be 2 upon 5. Now let us write down both the fractions, 1 upon 5 and 2 upon 5. Both fractions have equal denominator, that is 5. Thus, to compare them, we just have to compare the numerators. In the fractions, numerator 1 of fraction 1 upon 5 is smaller than the numerator 2 of fraction 2 upon 5. That is, 1 is less than 2. Hence, the fraction 1 upon 5 is smaller than 2 upon 5, or 2 upon 5 is greater than 1 upon 5. Thus, answer is 2 upon 5 is bigger fraction. Put the proper sign greater than or less than in the box between the fractions in each pair. Solution. 4 upon 4, 2 upon 4. Here the denominators are equal in both fractions. So we compare the numerators of the fractions. Numerator 4 is greater than numerator 2. 4 upon 4 is greater than 2 upon 4. Similarly, after comparing the numerators, 9 upon 10 is greater than 4 upon 10. 2 upon 7 is less than 5 upon 7. 2 upon 5 is less than 3 upon 5. 5 upon 7 is greater than 3 upon 7. 11 upon 17 is greater than 5 upon 17. Question 3. Draw figures to compare the fractions in each pair and say which one is bigger and which smaller. 3 upon 8, 5 upon 8. Solution. Now, to represent the fraction 3 upon 8 in figure, draw any figure a circle or rectangle. Check the denominator. It is 8. Now, divide the figure into 8 equal parts. Remember, whatever the denominator is in the given fraction, you have to divide the figure in that many equal parts. Now check the numerator. It is 3. Now, color 3 parts out of the 8 equal parts. Similarly, for the next fraction, draw the same figure. Now, check the numerator of the next fraction, 5 upon 8. It is 5. Now show 5 colored parts out of the 8 equal parts. Since the denominator of both fractions, 3 upon 8 and 5 upon 8 are equal, we will compare the numerators of the fractions. Now, 5 is greater than 3. Hence, answer is the fraction 5 upon 8 is greater than 3 upon 8. We will now understand how to arrange the given fractions in the ascending and descending orders. The denominators of these fractions are equal. Let us first revise the terms ascending and descending in simple words. Ascending order means from smallest to biggest. For example, given a few numbers, say 1, 4, 2. If we have to arrange these in ascending order, we will first check the smallest number of all the numbers. Here it is 1. The number bigger than 1 here it is 2. The biggest number of 3 numbers is 4. Thus, in ascending order of numbers, the smallest 1 comes first, then follows 2, and then the biggest 4. Thus, 1, 2, 4 is the ascending order of the given numbers. Descending order means from biggest to smallest. Take the same example, 1, 4, 2. Write the biggest number 4 first, followed by the number 2, then smallest number 1. Thus, 4, 2, 1 is the descending order of numbers. Let us summarize the example. Numbers given were 1, 4, 2. Ascending order of the given number is 1, 2, 4. Descending order of the given number is 4, 2, 1. So, just check the numerators in fractions with equal denominators. Arrange the numerators in ascending order and descending order, and hence the fractions. Let us solve an example from exercise 27. Question 1. Arrange given fractions in ascending and descending order. 7 upon 8, 3 upon 8, 5 upon 8. Solution. The denominators of the fractions are equal. Thus, compare their numerators. Numerators of fractions are 7, 3 and 5. 3 is the smallest followed by 5 and 7 is the biggest numerator. Hence, ascending order of numerators is 3, 5, 7. Thus, ascending order of fractions is equal to 3 upon 8, 5 upon 8, 7 upon 8. Now, descending order of numerators is 7, 5, 3. Thus, descending order of fractions is equal to 7 upon 8, 5 upon 8, 3 upon 8. Did you know that two types of fractions exist, namely proper and improper? Now what to do? We understand by the terms proper fractions and improper fractions. A fraction in which the numerator is greater than the denominator is called improper fraction. Example: 3 upon 2, 11 upon 9, 5 upon 3, 29 upon 17. In these examples, you can see numerators are greater than denominators of each fraction. A fraction in which the denominator is greater than the numerator is called proper fraction. Example: 9 upon 17, 11 upon 15, 5 upon 9, 23 upon 35. In these examples, you can see numerators are smaller than denominators of each fraction. Let us solve exercise 28. Question: separate the following fractions into proper and improper fractions. Make two columns, one of improper and other of proper fractions. The fractions with numerator greater than the denominator will be placed under improper fractions. The fractions with denominator greater than the numerator will be placed under proper fractions. Now let us understand clearly with the help of figures. What is meant by proper and improper fraction? Proper fraction: if one whole is divided into two equal parts, then each part is represented by the fraction 1 upon 2, that is half. In the figure of the one whole figure, half is colored. 1 is the numerator, 2 is the denominator. Denominator 2 tells us into how many equal parts the entire figure has been divided. Numerator 1 tells how many of parts we have taken into consideration. Since denominator is greater than numerator, 1 upon 2 is a proper fraction. Improper fraction. Now, let us consider an improper fraction 3 upon 2. In all the three circles, 3 colored parts, each is equal to half or 1 upon 2, have been shown. Now, 1 upon 2 taken 3 times means 3 upon 2. Let us understand this. 1 upon 2 of one circle plus 1 upon 2 of other circle is equal to 1 whole circle. Still 1 upon 2 of third circle is left. Thus, 3 upon 2 can also be written as 1 plus 1 upon 2. Hence, the colored portion is in all 1 plus 1 upon 2. In short, 1 plus 1 upon 2 is written as 1 and 1 upon 2. In fraction 1 and 1 upon 2, 1 is integer and 1 upon 2 is proper fraction. Thus we can see that 1 and 1 upon 2 is a fraction with a whole number in it or a mixed number. We will now solve exercise 29. Question 1. Identify the mixed numbers from the following. Answer: 2 and 3 upon 5, 3 and 1 upon 6, 2 and 5 upon 6, and 1 and 2 upon 7 are the mixed numbers. Question 2. Write the mixed numbers in words. Answer: 2 and 3 upon 4, 3 and 5 upon 7, 11 and 1 upon 6, 4 and 11 upon 13. Question 3. Write the following fractions. Answer: 5 and 7 upon 15, 9 and 3 upon 5, 13 and 9 upon 13. And now, let us see how we can convert an improper fraction into a mixed number. Let us take an example from exercise 30. Question: convert the following fractions into mixed numbers. 25 upon 3. Answer: in the improper fraction 25 upon 3, 25 is the numerator, 3 is the denominator. To convert it into a mixed number, first divide the numerator by the denominator. That is, divide 25 by 3. Arrange the numbers. 25 is divided, 3 is divisor. As we know, in table of 3, 3 into 8 is equal to 24. 3 into 9 is equal to 27. So we have to consider 3 into 8 is equal to 24. Since 24 is less than 25, write 8 in the quotient above 25 and subtract 24 from 25. We get the remainder as 1. In the similar way, we can solve the other sums. Conclusion: to convert an improper fraction into a mixed number, first divide the numerator by denominator. Then write the integer part of quotient and then write the remainder as numerator and divisor as denominator of the fraction part of the quotient. Lastly, let us learn how to convert mixed number into an improper fraction. To convert a mixed number into an improper fraction, multiply the integer and the denominator of the fraction. To their product, add the numerator. Write the number you get as the numerator. Write the denominator of the given fraction as the denominator. Let us understand this by solving examples from exercise 31. Question 1. Convert into improper fractions. 1. 5 and 3 upon 7. Solution: to convert 5 and 3 upon 7 into an improper fraction, multiply the integer and the denominator of the fraction. To their product, add the numerator. Therefore, numerator is equal to the denominator 7 multiplied by integer 5 plus the numerator 3. Therefore, we get 7 into 5 is equal to 35 plus 3 is equal to 38. Now, 38 is equal to numerator of the required improper fraction. The denominator 7 is equal to the denominator of the required improper fraction. Hence, answer is 5 and 3 upon 7 is equal to 38 upon 7. 17 and 1 upon 3. Solution: to convert 17 and 1 upon 3 into an improper fraction, numerator is equal to the denominator 3 multiplied by integer 17 plus the numerator 1. Therefore, we get 3 into 17 is equal to 51 plus 1 is equal to 52. Now, 52 is the numerator of the required improper fraction. The denominator 3 is the denominator of the required improper fraction. Hence, answer is 17 and 1 upon 3 can be written as 52 upon 3. 30 and 3 upon 4. Solution: to convert 30 and 3 upon 4 into an improper fraction, Numerator is equal to the denominator 4 multiplied by integer 30 plus the numerator 3. Therefore, we get 4 into 30 is equal to 120 plus 3 is equal to 123. 123 is numerator of required improper fraction. The denominator 4 is equal to denominator is the required improper fraction. Hence, answer is 30 and 3 upon 4 can be written as 123 upon 4. Exercise 31. Question 2. Match the following. 1. 1 and 5 upon 7 is equal to 7 into 1 plus 5 the whole upon 7 is equal to 7 plus 5 the whole 7 is equal to 12 upon 7. 2. 4 and 3 upon 5 is equal to 5 into 4 plus 3 the whole upon 5 is equal to 20 plus 3 the whole upon 5 is equal to 23 upon 5. 3. 9 and 2 upon 11 is equal to 11 into 9 plus 2 the whole upon 11 is equal to 99 plus 2 the whole upon 11 is equal to 101 upon 11. So children, after having solved all the different types of examples from each exercise, I am sure you all can solve rest of the problems on your own. So practice thoroughly. All the best. We will start with an interesting activity to learn about a half. Take a sheet of paper. Keep a pencil box with a rectangular shape on the paper. Draw the outline of the box. Now, cut over the outline of the rectangle. Fold the paper in such a way that the edges of the rectangles fit on each other. In other words, the fold should be in such a way that it divides the paper into two equal parts. Now, unfold the paper and draw a dotted line along the fold. We get two parts of the rectangle. Now, color any one part of the rectangle. Therefore, we can say that each part, that is the colored part, and the part which is not colored, both are half of the paper. Thus, from this we learnt that when a part is divided into two equal parts, then each part is called a half of that part. Now, let us do another activity to learn about a quarter. We will take the same rectangular plain sheet of paper. Fold it into two equal parts as done in half. Repeat the fold once again to meet the edges. In other words, fold the rectangle twice in the same way as we folded in half. Now, unfold it. Draw dotted lines on the fold. You will have 4 equal parts. Now, color any one part. The colored part of a paper is a quarter or 1/4 part of the paper. Thus, from this we learnt that when a part is divided into 4 equal parts, then each part is called a quarter of that part. Now, let us proceed further and do one more activity to learn about 3/4 or 3/4. Take a rectangular paper divided into 4 equal parts. This means it is divided into 4 quarters. Now, color 3 parts out of the 4. This means out of 4 quarters, 3 quarters are colored. Thus, the colored part of the rectangle is called as 3/4 or 3/4. And the part that is not colored is called as 1/4. Thus, from this we learnt that when a part is divided into 4 equal parts, 3 parts of it are together called as 3/4 or 3/4 of that part. Question 4. Write in the boxes whether the parts colored and not colored are half, quarter or 3/4. In the first figure, out of 4 equal parts, 3 parts are colored. Therefore, we can say that 3/4 are colored and 1/4 is not colored. In the second figure, out of 4 equal parts, only 1 part is colored. Therefore, we can say that 1/4 is colored and 3/4 are not colored. The third figure is divided into 2 equal parts. Out of it, 1 part is colored. Therefore, we can say that half is colored and half is not colored. The fourth figure is also divided into 2 equal parts. Out of it, 1 part is colored. This means half is colored and half is not colored. Operation on fractions. 2/7, 3/8, 5/4, etc. are fractions with different denominators. We also learnt about proper fractions, improper fractions, mixed numbers, etc. Let us now start with adding fractions with equal denominators. See the figure alongside. As you can see, the figure has been divided into 7 equal parts. So the denominators here will be 7. The first section in the figure shows 3 parts out of 7. That is, 3/7 is the first fraction. The next colored section shows 2 parts out of 7. Thus, the second fraction is 2/7. Thus, in the fractions 3/7 and 2/7, 3 and 2 are the numerators. 7 is the denominator. Thus, to add 3/7 and 2/7, we have to add numerators 3 and 2 only. Write 7 as the denominator of the fraction. Thus, 3/7 plus 2/7 is equal to 3 plus 2 the whole upon 7 is equal to 5/7. Thus, 3/7 plus 2/7 is equal to 5/7. Note: in mathematics, the terms altogether, sum of, in all stand for addition. Means, if the words altogether or sum of, in all are used, we know that we have to perform addition. Thus, in the figure, how much is 3/7 and 2/7 altogether? Solution: we have to add 3/7 and 2/7. In the figure, if we count all the colored squares, we can see that we have 5 parts colored out of 7 parts, and thus the fraction will be 5/7. Since the denominators in both fractions 3/7 and 2/7 are equal, just add the numerators only. Write the denominator as it is. What is our conclusion from this? We can conclude that when adding fractions with equal denominators, we add their numerators to get the numerator of the sum. The denominator of the given fraction is the denominator of the sum. Let us solve the problems of the given exercise 52 to understand clearly how to add fractions with equal denominators. Exercise 52. Look at the figure and add the fractions. Solution. Look at the given figure. We can see that there are 5 equal parts. We have to add the fractions 2 upon 5 and 1 upon 5. For this, add the numerators only. 1. Write the denominator as it is. Thus, 2 upon 5 plus 1 upon 5 is equal to 2 plus 1 the whole upon 5. Thus, 2 upon 5 plus 1 upon 5 is equal to 3 upon 5. We can confirm this by adding all the colored squares, that is, 3 colored squares. Thus, 3 will be the numerator. Count the total number of equal parts. This will be 5 equal parts. Thus, 5 will be denominator. Thus, the required fraction is 3 upon 5. Hence, confirmed. 2. Add 2 upon 9 plus 5 upon 9. Since the denominators are equal, just add the numerators of both fractions. Write the common denominators as it is. Therefore, 2 upon 9 plus 5 upon 9 is equal to 2 plus 5 the whole upon 9 is equal to 7 upon 9. 7. 5 upon 21 plus 2 upon 21 plus 6 upon 21. Adding only the numerators of all fractions and writing the common denominators as it is, we get 5 upon 21 plus 2 upon 21 plus 6 upon 21 is equal to 5 plus 2 plus 6 the whole upon 20. 8. 4 upon 23 plus 5 upon 23 plus 9 upon 23. Adding the numerators of all the fractions and writing the common denominators as it is, we get 4 upon 23 plus 5 upon 23 plus 9 upon 23 is equal to 4 plus 5 plus 9 the whole upon 23 is equal to 18 upon 23. Children, you can now try to solve the remaining examples of the exercise 52 on your own and practice. Now students, let us learn subtraction of fractions with equal denominators. Let us learn this with the help of figures. See the figures. If we have to subtract 1 upon 5 from 4 upon 5, let us see the steps for the same. As seen in the figure, there are totally 5 equal parts made. So, 5 is the denominator. 4 parts are colored. So, 4 is the numerator. Thus, the fraction becomes 4 upon 5. Since we have to subtract one colored part out of the 4 colored parts, cut out that part. Thus, there are only 3 colored parts now. Thus, subtracting 1 upon 5 from 4 upon 5, we get the fraction 3 upon 5. That is, 4 upon 5 minus 1 upon 5 is equal to 3 upon 5. Let us take an example of subtraction of fractions with equal denominators when the figure is not given. Example, subtract. 17 upon 9 minus 13 upon 9. Subtract only the numerator of second fraction from the numerator of first fraction. Write the common denominator as it is. Thus, 17 upon 9 minus 13 upon 9 is equal to 17 minus 13 the whole upon 9. Therefore, 17 upon 9 minus 13 upon 9 is equal to 4 upon 9. Thus, we can conclude that when subtracting fraction with the same denominators, we subtract the numerators to get the numerator of difference. The denominator of the given fraction is the denominator of the difference. Let us solve a few examples from exercise 53 based on the operation subtraction. Exercise 53. 4. 19 upon 23 minus 5 upon 23. Subtracting numerators of the second fraction from the numerator of the common denominator and keeping the common denominator as it is, we get 19 upon 23 minus 5 upon 23 is equal to 19 minus 5 the whole upon 23 is equal to 14 upon 23. 6. 37 upon 16 minus 11 upon 16. Subtracting the numerator of second fraction from the numerator of first fraction and writing the common denominator as it is, we get 37 upon 16 minus 11 upon 16 is equal to 37 upon 11 minus 11 the whole upon 16 is equal to 26 upon 16. 9. 13 upon 19 minus 4 upon 19. Subtracting the numerator of second fraction from the numerator of first fraction and writing the common denominator as it is, we get 13 upon 19 minus 4 upon 19 is equal to 13 minus 4 the whole upon 19 is equal to 9 upon 19.